Hello and welcome to today's math lesson. So first of all, guys, can we all turn to wave and say a big hello to our friends on camera? Hello. And we'll begin by doing our meditation sequence. So I will sit down, take 2 fingers, find our heart center, left hand on our laps, and close our eyes. And when you're ready, guys, you can open your eyes and come back to the room. Excellent. And next we'll do our stretch sequence. So let's stand up and push in our chairs. And we can begin by stretching up high to the sky. High as we can. And then let's go down low. Touch your toes. And then we can go back up high one more time. And this time, can we go tippy toe high? And while we're there, let's have a wave. Wave side to side. Excellent. And then back down, touch your toes one more time. And then stand up and have a shake. Arms and legs, shake it out. Shake it out. Hands on hips, and we can have a wiggle. Wiggle side to side. Stop. Another wiggle. Stop. Forwards, backwards, forwards, backwards, forwards, backwards, and stop. And next we can go round and round. Give our spines a nice stretch, round and round. And stop. And then we can go back the other way. Round and round the other way. And stop. And to finish, guys, we can do 5 claps. 1, 2, 3, 4, 5. Excellent, guys. Have a seat. So today, in math class, we're going to be learning about a different type of symbol. So who can tell me what this symbol represents, guys? Multiplication. Multiplication is correct. So let's spell that together. M-U-L-T-I-P L-I-C-A-T-I-O-N. So altogether, multiplication. Now, sometimes in math lessons or math books, you might hear it referred to as times. It can also be known as the times symbol. T-I-M-E-S. So it's important to note that multiplication and times mean the same thing. Like in previous lessons, addition plus, subtraction minus. Now we're talking about multiplication, so we'll be using the times symbol. So let's begin by doing a couple of simple multiplication sums so that we know what we're talking about. And we'll start very simply. What's that multiplication sum you can see on the board, guys? 2 times 2. Now what times means is we just take the number that we're timesing by a number of times. So how many times, guys? So 2 plus 2, you see, we just times the number that we're multiplying by the number that we have to begin with. So 2 times 2, correct, equals 4. Now let's do another one. How about someone give me a single digit number? 6, okay, we've got 6 times, how many? 2. We've had 2, give me a 3, okay. So what we do with multiplication or times is what's our first number? 6. And how many times do we have to multiply 6? Times 3. Okay. So 1 6 is 6. 2 6s, 12. 3 6s, 18. You see? We just times the 6s by the number of numbers we have to multiply. 6, 12, 18. So 6 times 3 equals 18. And this is the very basic way in which we multiply numbers. But in today's class, we're going to introduce ourselves to multiplication, and we're going to learn something called properties. Yes, we're going to learn about 4 different properties of multiplication. So let's write that phrase on the board, guys. Properties, P-R-O-P-E-R-T-I-E-S, of, O-F, multiplication, M-U-L-T-I-P-L-I-C-A-T-I-O-N. So altogether, properties of multiplication. And this is the basis of today's lesson, because what we're going to be learning about is 4 different properties, different ways in which multiplication sums can provide us with the same answer. And what we've got now is a PowerPoint presentation for our students to observe and listen to about properties of multiplication. So let's turn to look at the TV screen, guys. So let's take a look at our PowerPoint presentation, properties of multiplication. There are various ways to work out multiplication sums. Yes, a sum is the same as a problem. If we have a multiplication problem, we can also call it a sum. And in this picture here, we can see some multiplication sums. 5 times 3 equals 15. 7 times 8 equals 56. 6 times 3 equals 18. 4 times 7 equals 28. And the bottom one here, 3 times 9. 27. Well done, guys. So remember, multiplication is always about taking the first number and timesing it by the second number. For example, 5 times 3 equals 15, because 3 5s is 15. But now we're going to learn about the 4 different properties of multiplication. And the first one, the commutative property, is when 2 numbers are the same regardless of the order. Yes. Now let's look at some examples about what we mean about commutative property. 7 times 9.
Equals 63.
Really?
Yes.
Are you sure?
Yes.
Okay, let's see. 7 times 9 equals 63. Okay, now what commutative property means, how about if we swap the 7 and the 9 around? 9 times 7 equals 63. So you see, whatever way we have the numbers, we get the same answer. And that's commutative property. So we can say 63 is the commutative property of 7 times 9 or 9 times 7. You see, whatever way we have the numbers, the answer will still be the same if it's the same 2 numbers involved. That's what we call commutative property. So let's do one more. 8 times 3. 24. Well done. So therefore, if we swap the numbers round, 3 times 8 equals 24 again. Because it's the same numbers, but on different sides. Commutative property. So we can say 24 is the commutative property of 8 times 3 and 3 times 8. Excellent, guys. Well done. So you understand, whatever side the numbers are on, if it's the same numbers, we get the same answer. Commutative property. And commutative is hard to say. Now we'll look at the next property. We have 4, and property number 2, the associative property. Well done, guys. Associative property is when 2 or more numbers are the same regardless of the order. So let's take a look at associative property. Now, we have our sum here. Now, what do we remember from combined operations? Which part must we do first?
In the bracket.
Always in brackets, yes. So 5 times 2. 5 times 2 is 10. And then 10 times 4 equals 40. Okay. So that's one way to answer this sum. But what about 2 times 4? 8. And then 8 times 5 equals 40. Same answer again. But if you notice, the sums are different. First of all, we have to do 5 times 2. Then times that by 4. And in the second sum, 2 times 4 times by 5. But because we're using the same numbers each time, 5, 2, 4, you see? Even though the brackets are different, the answer is the same, 40. So we can say 40 is the associative property of 5 times 2 times 4 and 5 times 2 times 4. Well done, guys. Now let's look at another example, and this time you can give me the answers. So what's the first sum? 2 times 3 times 7. So which part do we do first? Which is 2 times 3 equals 6. So then 6 times 7 equals 42. Okay? Everybody agree? But how about if we do 3 times 7, 21, and then 21 times 2, 42. You see, same answer. 42 is the associative property of 2 times 3 times 7 and 2 times 3 times 7. Same numbers involved in a different sequence will give the same answer, 42. And now we're going to look at the distributive property. One more time. The distributive property. These words are quite long and hard to say, I understand. Is when the sum of 2 addends. Now the addends are what we call the parts in brackets. The sums in brackets are called addends. Is the same as the separate multiplication. So let's take a look at distributive properties. So you can see here 5 plus 4 equals 9. So our sum is 2 times 9, which we have written here, equals, let's see, equals 18. Well done. But we can do it another way too. We can just say, instead of 5 plus 4, we can just use the 2, 2 times 5 plus 2 times 4. So 2 times 5 equals 10, and then 2 times 4 equals 8. So 10 plus 8 equals 18. 18 is the distributive property of 2 times 5 plus 4 or 2 times 5 plus 2 times 4. You see, we can do it both ways. We can either use 5 plus 4 to get the 9, or we can simply just times 2 by the 5 and then 2 by the 4. Will give us the same answer. So let's do one more with distributive property. So 3 plus 4 equals 7. So the sum here, 5 times 7 equals 35. Well done. But how about if we do it the other way? 5 times 3 equals 15 plus 5 times 4 equals 20. So 15 plus 20 equals 35. So we can say 35 is the distributive property of 5 times 3 plus 4 and 5 times 3 plus 5 times 4. Note the two different ways to get the same answer. That's distributive property. And finally, our fourth way. And the next way is the most simple. Ready for this, guys? The multiplicative identity property is when a number is multiplied by 1. The product or the answer, product is another word for answer. So the product is that number. These are very simple. If we're multiplying by 1, the answer will always be the number. For example, 5 times 1 equals 5. 200 times 1 equals 200. If we multiply only by 1, the answer is always the number, because we're only timesing by 1. And if it goes the other way, it's the same. 1 times 4,258. What's the answer? 4,258. You see? Timesing by 1, it's always the same answer. And this doesn't matter how many digits. 23 times 1? 23. 846 times 1?
846.
1 times 2,943 equals
2,943.
Excellent, guys. And this is called, ready? The multiplicative identity property. When we times the number by 1, the answer is always the number. Any questions, guys?
No.
That was great. Well done. Welcome back to class. We hope your students enjoyed the PowerPoint presentation so that they can begin to understand the different ways that we can do multiplication problems using the 4 different properties that we will learn about more soon when we do our board exercise. But for now, guys, it's time for our stretch sequence. So let's stand up and push in our chairs. Okay? And for this exercise, we'll begin with some rotations. Left, right, left, right, left, right, left, right, left, right. Excellent, guys. And now we'll do 5 stretches to our right. 1, 2, 3, 4, 5. Now we'll do 5 stretches to our left. 1, 2, 3, 4, 5. Excellent, guys. Now have a shake. Shake it out again. Arms and legs, shake it out. And to finish, we're going to do 5 star jumps. 1, 2, 3, 4, 5. Excellent, guys. Have a seat. So now we're going to do a board exercise where we will learn how to do multiplication problems using the 4 different properties that we've seen in the PowerPoint video. So first of all, we'll go through our different, ready guys, properties of multiplication. Okay, and the first property that we're going to look at, commutative. Okay, so property number 1, commutative. C-O-M-M-U-T-A-T-I-V-E. Commutative. And what commutative means is that no matter if we have two numbers, whatever way we multiply the numbers, we'll get the same answer. For example, 5 times 8 equals, what do we think, guys? 40. 5 times 8 equals 40. Because we're using 5 times 8. But how about if we use 8 times 5? I will now choose a student to come forward to work out what the commutative property of 5 times 8 and 8 times 5 really is. So let's see who can go first. And the pen is with Pangpon. So Pangpon can come forward and demonstrate for us the commutative property. So we're using the same numbers, guys. We already know 5 times 8 equals 40. So how about 8 times 5 equals 42? Excellent, Pangpon. You see, because we're using the same two numbers, 8 times 5, it doesn't matter what side we put them on. If we use the same two numbers, we're always going to get the same answer. So we can say 40 is the commutative property of 5 times 8 and 8 times 5. Pangpon, that was excellent. High five. Big round of applause for Pangpon, guys. And next, we're going to look at our next property, associative property. But first of all, I need to clean the board. So, associative, guys, we spell A, S, S, O, C, I, A, T, I, V, E. Associative property. Now, what we need to do with associative properties, they're slightly more advanced than the commutative. What we will always have is we will have numbers in brackets. For example, here we have 6 times 3, and then times 2. So which sum do we do first? If we have a math problem, we always do the sum in brackets first. So 6 times 3 equals 18. 18 times 2 equals 36. So you see, that's one way to work out our multiplication problem. But how about if we have 6 times, then open the brackets, 3 times 2. Now, I would like another student to come forward and work this one out for me. Okay, and now the pen is with Prel. So I'd like to invite Prel to come forward and work out this associative problem for me. So where do we start, guys? Do we start here with number 6? No, always brackets. 3 times 2 equals 6. Okay, so now we need to work out 6 times 6, which is 36. Ready, guys? This is what we call associative property. Because we're using the same numbers all the time, doesn't matter which ones are in brackets, we get the same answer. So we can say 36 is the associative property of 6 times 3 times 2, or 6 times 3 times 2. Because we're using the same numbers again, we get the same answer. And Prel, that was brilliant. High five. Big round of applause for Prel, please, guys. And now, onto property number 3, but after I've cleaned the board. And the third multiplication property that we've learnt about today is distributive. Yes, distributive property. D-I-S-T-R-I-B-U-T-I-V-E. Distributive property. Now what distributive means is that we need a sum similar to the last one to begin. Let's have 7 times 2, but then we use a plus. So guys, which problem do we answer first? Always brackets. 2 plus 7 equals 9. So then 7 times 9 equals 63. Okay, but there's a second way that we can work out our distributive property. What we can do instead is we can just take the 7, times it by the 2, and then the 7 again, and times it by 7. So let's see who can come forward and work out this problem for me. I know Lakgau has the pen. Lakgau can come and work out the distributive property for us. So guys, any brackets this time? No brackets, so we can start here. So first of all, 7 times 2 equals 14. Excellent, Lakgau, well done. And then our second problem, 7 times 7 equals 49. Okay, so we have our answers to the 2 multiplications. Then we need 14 plus 49 equals 63. So you see, we reach the same answer again, the distributive property. So we can say 63 is the distributive property. Well done, guys. 7 times 2 plus 7. And 7 times 2 plus 7 times 7. So you see the 2 different ways of getting the same answer using distributive properties. Lakgau, that was brilliant. High five and a big round of applause for Lakgau, please, guys. And now onto our final and perhaps most simple way to work out a multiplication property. But let me clean the board first. So our fourth and final way of looking at multiplication properties, ready guys? The multiplicative. Okay, M, U, L, T, I, P, L, I, C, A, T, I, V, E. Oh. So let's say together, multiplicative. Identity. I-D-E-N-T-I-T-Y. Multiplicative identity. Now what this simply means is that if we start with a number and times it by 1, the answer will always be that number because we're only timesing by 1. For example, not yet. 4,253 times by 1. equals
4,253.
253. So let's see who can answer this multiplicative identity problem. I know Net can answer this one for me. Net, come forward and join me, please. Let's have Net demonstrate how to answer this multiplicative identity property. So, what number do we have, guys? 237. And how many are we timesing it by? 1. So what will our answer be, Net? Yes, it will always be the same. Excellent, Net. Whenever we're timesing a number by 1, the answer will always be the number. And this is what we call multiplicative identity property. So ready, Net? 237 times 1 equals... Yes, these are the easiest of all because we have the answer already. Whenever we times a number by 1, the answer is always that number. And Net, that was brilliant. High five. Big round of applause for Net, please, guys. A big round of applause for everybody for doing a great job. And now it's time for our worksheet part of the lesson. So teachers, make sure every student in your class has a worksheet. And on today's worksheet is a list of 8 problems, all involving multiplication and the properties that we've learned about earlier. We have commutative property, associative property, distributive property, and multiplicative identity property. And they're all contained within our sums here. What our students need to do is read through each of the various sums and then answer them in the spaces provided. And they can show their workings out too. But what's the first thing to do, guys? Write our names on top. And give our students around 12 minutes for this activity and just monitor the class, help them with anything they need. So Chu, this one's for you. You're welcome. Pat, for you. You're welcome. Nadia, for you. You're welcome. Ned, that's yours. You're welcome. Down for you. You're welcome. Prel, you're welcome. Bangpon, you're welcome. And Lakau, you're welcome. So names on top, guys, and then answer the problems. But look at them and answer them independently. But I think you'll notice a relationship between them. And thinking back to our properties, see if you can remember which properties they represent. But the main thing is to answer the problems correctly. And if you need any help, let me know. For example, the first one, 8 times 9, 72. So then what do you notice about number 2? 9 times 8, 72. And that's what we call commutative properties. The same numbers on opposite sides give the same answer. What have we got? Always remember, do the sum in brackets first, guys. So let's see next. 6 times 4. 6 times 4. What do we think? 6 times 4. 24. Well done. 6 times 4. 24. But then, times 3. So 24 times 3. 72. And that's your final answer. Okay, 4 times 6
4 times 6 equal 24.
equals 24 times 5.
50.
Correct. So then 5 times 4
I don't know, equal 20.
equals 20. 5 times 6, 30. 50. Perfect. Okay. So 4 times 6. 24. So make sure to read the problems carefully, guys. Everybody's doing a great job. Welcome back to class. We hope your students enjoyed the worksheet activity where they had to work their way through the various multiplication problems. And try to remember, guys, what type of properties were they? We had commutative, associative, distributive, and finally, multiplicative identity. And everybody did a great job, so very well done, guys. And that's all we've got time for today's lesson. So we hope you've enjoyed our introduction to multiplication and learning about, one final time, guys, properties of multiplication. And we'll see you again soon for the next lesson. So can we turn to wave and say goodbye, guys? Goodbye. Bye-bye. See you again soon.